Section K, Qualitative Analysis. 11.1 Experiment. Aim to determine one cation and one anion in the given salt. Requirements: test tubes, beaker, china dish, funnel, burner, tripod stand, filter paper, etc. Cations: Pb2 positive, Cu2 positive, Al cube positive, Fe cube positive, Zn2 positive, CO2 positive, Mn2 positive, Ni2 positive, Ca2 positive, Ba2 positive, Sr2 positive, Mg2 positive, As cube positive, NH4 positive, star Cd2 positive, star Na positive, star K positive. These are basic ions. Anions: NO2 negative, NO3 negative, Cl negative, Br negative, I negative, CH3COO negative, H2 negative, SO3 2 negative, CO3 2 negative, PO4 3 negative, C2O4 2 negative, star BO3 cube negative, SO4 2 negative. These are acidic ions. Note: insoluble salts excluded. Theory: qualitative inorganic analysis deals with the detection and identification of acidic and basic radicals present in an inorganic salt or a mixture of salts. An inorganic salt is formed when an acid reacts with a base. For example, an inorganic salt consists of two electrically charged species called radicals. A radical is an atom or group of atoms bearing a net positive or negative charge. The positively charged radicals derived from base are called the basic radicals or simply the cations. The negatively charged radical derived from an acid are called acidic radicals or simply the anions. For example, in sodium chloride, Na positive, Cl negative. The sodium Na positive part is derived from the base Na positive OH negative and is therefore basic radical, while chloride Cl negative part is derived from the acid H positive Cl negative and is therefore acid radical. It is possible to detect the acid and the basic radical present in a given salt by performing certain tests on them. These tests can be carried out both in solid state as well as in solution form because each radical has its own characteristic properties. Systematic qualitative analysis of a salt involves following steps: preliminary test or dry test for acid and basic radicals, identification of acid radicals, confirmation of acid radicals by wet test, identification and confirmation of the basic radicals by wet test. Preliminary test or dry test for acid and basic radicals. These are performed with dry salt but do not provide any definite, conclusive information about the radicals. Sometimes they do provide valuable information about radicals. Some of the important preliminary tests are physical examination, dry heating test, charcoal cavity test, charcoal cavity cobalt nitrate test, flame test, borax bead test. Identification of acid radicals. Some preliminary tests like dry heating test give indication about some acid radicals. Following tests are used for identification of acid radicals: dilution H2SO4 test, Concentration H2SO4 test, independent group SO4 2 negative, PO4 cube negative, BO3 2 negative test. Confirmation of acid radicals by wet test, done by preparation of water extract WE if salt is soluble in water, or sodium carbonate extract SE if salt is insoluble in water. It is neutralized with CH3COOH when used for sulfides, phosphates, or with dilutes HNO3 while confirming chlorides, bromides and iodides, or dilutes HCl while confirming sulfate are used for confirming acid radicals. Identification and confirmation of basic radicals by wet test. Preliminary tests give some indication about basic radicals. However, the basic radicals are detected and confirmed by carrying out a series of tests in a systematic way. For this purpose, the cations are divided into various groups. The basic radicals of a particular group are precipitated from their original solution OS by a specific reagent called group reagent, and then confirmatory tests are carried out. Note, in order to make the detection of the radicals accurate and easy, the students are advised to follow the following points sincerely. Never apply any preconceived guess to a test or the result. Do your work independently, honestly, and confidently. Strictly adhere to the systematic scheme of analysis. Shortcuts and unsystematic work may lead to failure. Keep your apparatus clean. Do not carry out the test in a test tube having even traces of impurities sticking with its walls. Use distilled or deionized water for analysis. Use only the specified quantity of the reagent. Preferably, make use of droppers in case of solutions. Do not carry any of the reagents to your seat. Also, do not change their order on the shelves. Replace the reagent bottle at its place after use. Do not pour the reagent back into stock bottle once it is taken out. Do not place the stopper of reagent bottle on the table. Hold the stopper between fingers of the hand in which bottle is held while transferring the reagents. Use your own glass nozzle for passing H2S gas. Wash it with water before and after using every time. Do not work only mechanically. Try to understand the theory involved in the analysis. Record all the observations neatly during experimentation in a notebook. Do not use filter paper or stray piece of paper of the purpose. Physical examination of the salt. Test, observations, inference. Color. Note the color of the salt. Blue or bluish green. Cu2 positive may be present. Green. Ni2 positive may be present. Dark brown. Fe cube positive may be present. Light pink or flesh color. Mn2 positive may be present. Rose red or violet. CO2 positive may be present. White. Absence of the above mentioned ions and Na positive, K positive, Ba2 positive, Zn2 positive, NH4 positive. SO4 2 negative may be present. Smell. Mix a little salt with a drop of water and rub between your fingers. Vinegar like CH3COO negative may be present. Rotten egg. S2 negative may be present. SO2 gas. SO3 negative may be present. Ammoniacal. NH4 positive may be present. Density. Feel the weight of a little salt by replacing it on a piece of paper and holding it on your palm. Heavy. Pb2 positive, Hg2 positive, or Ba2 positive may be present. Light or fluffy powder, Al3 positive, Mg2 positive, Ca2 positive or Zn2 positive may be present. Deliquescence. Salt absorbs moisture and becomes paste-like. If colored, may be CuNO3 to FeCl3. If colorless, may be ZnNO3 to chlorides of Zn2 positive, Mg2 positive, etc.